Hello students, today we are going to discuss about intervals as subsets of R. What is the meaning of R? Here R is nothing but real numbers. So what is the meaning of intervals? Intervals in the sense a certain limit or certain period of time. For example, in our regular class, when we have a timetable, we have a certain period of time, we have like interval. Interval in the sense, a time period we have. Suppose, for example, lunch break. Our lunch break is 12:30 to 1:10. So here we have a certain period of time. That is nothing but called interval. Means here in numbers also we have intervals. What is the meaning of intervals and how to consider those intervals and how many types of intervals we have, that we are going to discuss here. Very briefly we discuss this concept. Basically in mathematics we have three types of brackets. The brackets are square brackets, open brackets and flower brackets. These are nothing but called square brackets. These are nothing but called open brackets. These are nothing but called flower or curly brackets. So we have total three types of brackets: square brackets, open brackets and flower brackets. Now one bracket gives us one information for us. As we know that flower brackets, it is nothing but sets. When you give a certain objects within the flower brackets, that representation is known as what? Sets. That is our present concept. Now, what about these two brackets, square brackets and open brackets? What it gives us? What it gives us? For example, when we have let A and B are two real numbers and A less than B. What we are taking? We are taking A and B are two real numbers and I have a relation that A is less than, means A is smaller than B. Now we have total four conditions. For example, case 1, x such that A less than, x less than B. Case 2, x such that A less than or equal to, x less than or equal to B. Case 3, x such that A less than or equal to, x less than B. Case 4, x such that A less than, x less than or equal to B. So here we have total four conditions. I have given total four cases. In those four cases, what the conditions we have? What are the conditions we have? Now, as we know that A and B are two real numbers and also A less than B. Now a real number x between a and b. Between a and b. If you observe all these statements are looks like same. Everywhere you have x is between a and b. X is between a and b. X is not less than a and x is not more than b. All the cases looks like same, but a minute observations we have, minute differences we have. What are they? Here we have less than. Here we have less than or equal to, less than or equal. Here we have less than or equal to. Here we have less than, and here we have less than or equal. Now, what is the difference between less than and less than or equal? When we use less than or equal, what is the difference we are going to get, that we are going to observe here? Now, what is our concept presently? Interval. Interval in the sense, x has a certain boundaries. X has a certain boundaries. What are the boundaries we have? A and b. So x is between a and b. As I told you earlier, our lunch break, whenever you want, you can't go and eat. Whenever they specify a particular time of a period of time, during that period of time only you should have your lunch. Means 12:30 to 1:10. This is our boundary. So between this period of time or interval of time, you have to finish your lunch. No sir, I am not getting hungry during the time, I will eat 2 o'clock. No one will give permission. In the same way, here x is also having a certain boundaries. X is not less than a and x is not less than b. Means that x has certain limit. Means certain interval. That's why these are called intervals as subsets of real numbers. For example, 2 less than x less than 5. 2 less than x less than 5. We have infinite real numbers. Infinite real number, where is your x value means? It has some boundaries. It is not less than 2 and it is not more than 5. X is always lie between 2 and 5. It may be nearer to, or it may be nearer to 5, or it may be in between 2 and 5. That is nothing but what? Interval. Interval means we should have one limit. Means we should have some boundaries. So within the region or within the boundaries, our required value has to be exist. Now, when we have less than, how to represent it? Now I can represent in the way x belongs to open brackets a comma b. Here a less than x less than b means x is not equal to a, x is not equal to b. We are not considering a and b values. In between a and b values we are considering. The meaning of less than means x is between a and b, but not equal to a, not equal to b. So we are using this open bracket. So x belongs to open brackets a comma b. So whenever we have the meaning of open brackets a comma b, means that we are not considering the values of a and b. This is nothing but called open interval. Open interval of a and b. Open interval. We have intervals. Open interval, closed interval, closed, open, open, closed, and all. Open interval means excluding a and b between the values we are considering. Now coming to the case 2, x such that a less than or equal to x less than or equal to b. Here less than or equal means that x may be equal to a, may be equal to b. There is a chance of that x may be equal to a and x may be equal to b. Means that we can write here x belongs to closed brackets a comma b. See the difference? Wherever we have purely less than, we are using open brackets. Wherever we have less than or equal to, we are using square brackets. Here the square bracket gives us including a and b. Here excluding a and b. Here including a and b. These are nothing but called closed interval. Closed interval of a and b. Closed interval of a and b. Now case 3. What is case 3? X such that a less than or equal to x less than b. Now you can observe. Here I have less than or equal to and here I have only less than. Means that x may be equal to a. X may be equal to a but not equal to b. Means one side we have less than or equal to, another side we have only less than, which is nothing but we write symbolically x belongs to. Wherever we have less than or equal to, then we have to write square brackets. Here we have only less than, only we have less than. Less than means we have to write open bracket. See the difference? Here I have less than or equal to. That's why we are using square brackets. Here I have only less than. That's why we are using open. Means including a, excluding b. Means our x value starts from a. Starts from a, but not end with b. Just before. Just before means we are considering the value of a but not b. This is nothing but called. This is nothing but called close to a and open to b. So this is which kind of interval it is? It is an interval of close to a and open to b. Next, the last, x such that a less than, x less than or equal to b. A less than, x less than or equal to b means that we are not including a. We are not including a, but we are including b. We are not considering a, but we are considering the value b. Means that x belongs to open a, closed b. Open a, closed b. It is nothing but open to a and closed to b. This is another kind of interval. So we have total 4 types of interval. One is open interval, closed interval, closed and open and closed. Where we are using small brackets, where we are using square brackets, you might have got that. Means wherever we have less than or equal to means square brackets. Only less than means open brackets. These are the intervals. Whenever you have this kind of notation, means set builder form can be representing interval form. Whenever you have interval form, that can be written in the set builder form. So vice versa means here I have set builder form notation. I can write it as x belongs to open interval a comma b. If they have given x belongs to open interval a comma b, can be expressed in this way. Here also same. So vice versa. This is about intervals concept. Interval means you should have one limit, means boundaries. The value means the real number has a certain boundaries. It has lower boundary and it has upper boundary. Both boundaries we have. Within that region only, the value of x exists. This is about intervals as subsets of real numbers. Now, based on this concept, we have few more problems that we discuss. Now, we continue how to represent the intervals on a number line. Just before, we have seen what are the intervals: closed intervals, open intervals, closed and open, open and closed, that and all we have seen. Now, how to locate or how to represent those intervals on a number line? Now, let us see the first one. Here we have this closed interval a comma b. As we know that closed intervals means what? We are going to include the values a and b. Closed interval means including the boundaries. Open interval means excluding the boundaries. Here we are talking about closed interval a comma b. Means that if it is a number line, here I have the value of a and here I have the value of b. Now, closed interval means we are going to consider including the value a, and the value b. This entire means starting from a ending to the b and between the values. All the values we are going to consider. So this is nothing but closed interval a comma b. This entire region we are considering as closed interval a comma b. Whereas open interval a comma b means excluding the boundaries, means we are not considering a and we are not considering b. Only between the values, means only this is the area we are considering. So we are not including a, we are not including b. Now next one, closer to a, open to b, means closer to a. Here we have a, we have closed bracket. Closed bracket means including a. So, starting with a and up to b. Starting with a up to b. We are not considering the b value. We are not considering the value of b. Here, open to a and close to b. Open to a, close to b means not considering a, this entire region, and also the b, means this is the region we are considering. This is the region we are considering. So, closed interval means both boundaries are included. Open interval means excluding the boundaries. Closer to open, open to close. This is nothing but representation the intervals on a number line. And we have infinity. Wherever you have infinity, always we have to use open interval. Infinity means we don't know what is the exact value, so that we can't use the closed interval. We have to use always open interval. Means that, for example, natural numbers. If I take 1 to infinity, you can use closed interval 1, open interval infinity. These all are what? Natural numbers. Whole numbers, closer to 0, open to infinity. Integers, minus infinity to plus infinity. Both sides we have to use the open intervals, because infinity means it is not your exact value, so that we have to use the open intervals. Negative integers. Negative integer means it starts from -1 and it goes to infinity. So open minus infinity to -1. This is the way how to represent an intervals. Now, based on these intervals, let us have some problems. So, subsets we discussed, intervals we know. Now, based on these subset concepts and interval concepts, let us have exercise problems. Now, let us discuss exercise 1.3. In this, the first Roman, make correct statements by filling in the symbols subset or not subset in the blank spaces. We know that this is the symbol is called subset. As we know that we have a lengthy discussion about subsets and we have discussed with many examples. Subset means subpart. Our classroom is a subpart of a school, means it is a subset. Like that, we discussed many examples. Now, let us see here, three statements are given. Now, these three statements we have to make correct statements using the appropriate symbol, whether the subset symbol we have to use or not subset symbol we have to use. Now, the first statement, set 2, 3, 4 dash set 1, 2, 3, 4, 5. So always left hand side we should have the small set, right hand side we should have the bigger one. Then only we can use subset symbol. Here left side I have with 3 elements, right side I have with 5 elements. So the left hand side set is smaller one, right hand side set is bigger one. Now compare the elements. Left hand side, what are the elements we have? 2, 3, 4. All these elements are also there in right hand side set also. Here I have the elements 2, 3, 4. The same elements are there here also. So that what we can use, it is a subpart of this set. So I can use the subset symbol. All these elements are present in the set. So that it is nothing but a part of this set. It is a subpart of this set. Now the fifth one, x such that x is a triangle in a plane dash x such that x is a rectangle in the plane. Triangle. Triangle means what? Which is a closed figure bounded with 3 line segments. Rectangle is what? It is a quadrilateral, means it is also a simple closed figure bounded with 4 line segments. So there is no way relation between triangle and rectangle. There is no way relation with triangle and rectangle. Triangle is a different shape, rectangle is different shape. So when there is no relation between them, how can we say that they are subset? It is not a subset. So we have to use it, not subset. So set of triangles, set of rectangles are not subsets. And the next one, x such that x is an even natural number. Even natural number. What are the even natural numbers we have? 2, 4, 6, 8, 10, 12, 16 and so on. X such that x is an integer. Even natural numbers. What are the even natural numbers we have? 2, 4, 6, 8, 10, 12 and so on. Here integers. Integers is what we have? Minus infinity, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8 and so on up to infinity. Now once if you observe these two sets, here I have the element 2. Here also I have the element 2. Here I have the element 4. Here also I am having the element 4. 6. Here I have 6. 8. Here also I have the element 8. Like that, if you keep on continuing the integers, all these integers are part of an integers. These are what? Even natural numbers. All these are even natural numbers are the part of an integer. Means it is a subpart of that. What symbol we use? Definitely we use subset symbol. So just you need to observe it very carefully. Very easiest concept. It is not that much of difficult concept. There is no formula. There is no calculation. Nothing is. Just only the observation. So left hand side we should have small set. Right hand side we should have bigger one. These are called subsets. These are called supersets. Our classroom is a subset. Our school is a superset. This is about first Roman. In this Roman we have total 7 problems. We discussed here 3 problems. Here we have Roman number 2. Examine whether the following statements are true or false. Here they have given some statements. We need to identify whether the statements are true or false. Let us see how to identify. The first one is given. Set A comma B is not subset to set B, C, A. Here I have left hand side one subset, means one set. Right hand side, right and left both I have a sets. And left hand side I have a smaller one. Right hand side I have a bigger one. Now whether these two are subsets or not means what we need to do. Left hand side, whatever the elements we have, we need to observe that whether all these elements are present in the right hand side set or not. Here we have some elements. Here also we have some elements. We have to compare the elements. Now, left hand side, what are the elements we have? A, B. Right hand side we have B, C, A. Here I have the element A and the same element is also there here. Here I have the element B. The same element is also there here. Means that all these elements are presented in this set also. Means what we can say? It is a part of this set. Part of this set means we have to use subset symbol. But what is given does not, means it is a false statement. It is a false statement. Actually it is a subpart, but they said that not subset, which is a false statement. Now the second one, set A belongs to set A comma B comma C. Here I have a set and here also I have a set. Here what is the element I have? A. And here what is the element I have? A. Now these two elements are same. Means that it is a subpart of this subset. It is a subpart of this set. Now here they have given the symbol belongs to. You have to know a clarity between the belongs to and subset. Belongs to symbol we use for elements. Belongs to symbol used for elements. subset we use for sets. This is the symbol we use for sets. This is the symbol we use for elements. Now just you observe, here we have element or set. We have set. They said that this set belongs to this set, which is wrong. This set is subset of this set. So it is a false statement. Which is a false statement. For example, A belongs to A comma B comma C is there, which is a true. This statement is true because here A indicates an element. Yes, this element is presented in this set, so it is belongs to. This is true statement. Set A is subset to set A comma B comma C. It is also right one. These are the two right statements, but it is wrong statement. Here belongs to should not be. Here subset has to be. Instead of belongs to, if you have subset, this statement gets true. But here what is given? Belongs to is given. So that this statement is also false statement. And the last one. X such that x is an even natural number less than 6. X such that x is an even natural number less than 6. What we have here? 2 comma 4. They given the symbol subset. Next, x such that x is a natural number which divides 36. Which divides 36. What are the divisions of 36? 1, 2, 3, 4, 6, 9, 12, 18 and 36. These are the divisors of 36. Now, here I have 2 elements a set and here I have 9 elements with a set. So, which is the smaller one and this is the bigger one. Now, here they said that this is the set is subset of this set, whether it is right or wrong. Right or wrong in the sense, we have to check the elements. Here, what is the element? We have 2. The same element 2 is also there here. 4. It is also there here. Means that all these elements are presented in this set also. Means we can say that it is a subset of this set. The given statement is true. The given statement is true. The first one is false one, fifth one is false one, sixth one is true. You need to observe it and you have to know that difference between belongs to and subset also. Belongs to symbol we use only for elements. Subset symbol we use only for sets. That you have to remember properly. Now let us discuss 6th Roman, which is depending on the intervals. So just before we have different types of intervals and we know how to convert the set builder form into intervals, intervals into set builder form, and how to represent on a number line, that and all we have seen. Now based on that, let us have a few problems. Write the following as intervals. Here, under this heading, you have 4 sub-problems. All these 4 problems are in which form? Set builder form. These all are in which form? Set builder form. These set builder forms we need to represent like intervals. Very easily we can represent. The first one you see that, right? We have an element x. X belongs to. Where is the x value? The value x is -4 less than x less than or equal to 6. This statement is more important for us. -4 less than x less than or equal to 6. As I told you, when we have less than symbol, whenever we have less than symbol, we have to use which bracket? Open bracket. So, open bracket, minus 4 comma. And here what is the number we have? 6. For 6, what is the symbol we have? Less than or equal to. Less than or equal means close. Less than means open bracket. Less than or equal to means square bracket. That's all. So, very simple. This entire we have converted as like intervals. X belongs to open interval minus 4 comma 6. Similarly, the second one, minus 2 less than x less than minus 2. Both we have less than, means both sides we have to use open brackets. So x belongs to minus 12 comma minus 10. Open brackets, minus 12 minus 10, means x belongs to open interval minus 12 comma minus 10. And the third one, what is given? Less than or equal to less than. Here I have less than or equal to, means x belongs to square brackets 0 comma 7 open bracket. Here I have less than or equal to, so that I am using square bracket. Here we have only less than, that's why we are using open bracket. So finally x belongs to close to 0 to open 7. This is the another interval. Now the last one, less than or equal to less than. Both we have less than or equal to. When both we have less than or equal to, means what? X belongs to closer to 3 comma closer to 4. So wherever we have less than or equal to, there we need to keep square brackets. Wherever we have less than, strictly less than, means we have to use open bracket. This is about 6th problem. Now 7th problem we have, when intervals are given, how to convert into set builder form. This is what, when set builders are given, we need to convert into list form. Sorry, in intervals. Next problem, when intervals are given, how to represent in the set builder form. That we see the 7th question. Now let us see the 7th problem. Write the following intervals in set builder form. The previous problem, when set builder form is given, we convert in form of intervals. Now intervals are given, we need to write in the form of set builder form. Very simple problems. So solution, x such that x belongs to real numbers. Now what are the numbers are given? Minus 3, 0. So minus 3 less than x less than 0. And you need to observe the brackets. Here what are the brackets? We have open brackets. Open bracket means we have to write only less than. Less than we have to write. Now the second one, closed interval 6 comma 12. Here you have what are the brackets? Square brackets. Square bracket means less than or equal to. So x is such that x belongs to R, 6 less than or equal to x less than or equal to 12. Wherever we have open brackets, we have to keep less than symbol. Wherever we have square brackets, we have to keep less than or equal to symbol. So less than or equal. Less than means strictly less than. Open brackets. Less than or equal to square bracket. That small observation you have to remember. Now the third one. Third one, what is given? One side you have open bracket, another side we have square bracket. So here open bracket means less than. Here square bracket means less than or equal. So x is such that x belongs to R, 6 less than x less than or equal to 12. Here square bracket means this side, left hand side you have closed, right hand side is open, means x is such that x belongs to R minus 23 less than or equal to x less than 5. So wherever we have square brackets, we are going to use less than or equal to symbol. Wherever we have open brackets, we are going to use small brackets, less than symbol. This is nothing but converting intervals into set builder form. So with this we stop our calculation and our class today. Still there are few models in our exercise number 1.3. Those we discuss in our next class. So try to complete the problems which we did not discuss in our class. A few models I am discussing. The remaining problems you have to try at your home. Hari Om.